here. So this is shift, this is register, girls, and here you can see that there you can see we have 4 flip-flops. So this, that means it is 4-bit register, and here you can see this is D flip-flop. And girls, as I taught you in chapter 5. In chapter 5, I taught you about the direct input. So you can see here we have the R, which is the direct input, and we are using reset button, and same, all are connected together with the same point. So girls, for the direct inputs, this is in registers, we need to connect the direct inputs because it is very difficult to give the reset to each flip-flop individually because it will take too much time. And you know, girls, in register, not always we are going to use only 4-bit register. Maybe sometimes we are using 32-bit register, 64-bit register, means in that one there will be 64 flip-flop. So that will be very difficult to give the individual command to each register, to each flip-flop. So that's why we have the direct inputs. So if I want to be reset of all flip-flops together at the same time, so I can give the reset command and all will be reset. Similarly, the same concept for the set also. If I want to set them, all flip-flop, I want that there should be the set, so we can connect with the set point. Okay, clear?
Yes, clear.
So now here, this is the clock. We need to see the waveform, and you know very well this is the D flip-flop. So for D flip-flop, the truth table is very much clear to you. If I am giving 0, so what will you get for D flip-flop, girls?
0.
If I am
Same.
giving, yes, then
D.
same. So let's see what is the input we have to give here. The input is this I3, I2, I1, I0. So now we need to plot the waveform for A3, A2. So first I3 is there, so I will plot the waveform for A3. So if I want to plot the waveform for A3, girls, so you know that before the clock, here is no clock. Is there any clock?
No. 0.
No. If no clock, then
0.
0. 0, why 0? Because it will work
Initial
as
value.
an initial
By
value 0.
default.
Yes, so 0, correct.
Okay.
Now it is the time where the result will change because I am getting the clock here. So I have I3. If I check I3, I3 has 0, I3 has 1. Means there are 2 values
Very
for
simple.
for the same clock. So tell me which value I need to choose.
0.
0. Why?
The beginning is 0.
The beginning, very good. Yes, the initial value, the first value you need to choose because your clock will start from here. And always, if you are positive age triggering or negative age triggering, what is the first value out of this? So the first value is 0, so I will choose 0. So that's why D is 0, I will consider, so 0, so the A3 will be 0 till to the next clock. Clear or not?
Yes.
Clear.
Okay. Now check again here the result we need to check. Here is 1, here is 0. So tell me what value we need to choose.
1.
1.
1. What is the first value, girls? 1 or 0?
1.
1. So I will choose 1.
Why, miss?
Yes, why? Here, look, I told you if you have if you are going to check the inputs and you have 2 values for that particular clock. Look, for this clock, we have 2 values for I3. I have
Yes.
1, I have 0 also.
Yes.
So we need to choose always the first value. So before the value was 1, so the 1 is the first or the 0 is the first?
1.
1, so I will choose 1.
Okay, and the previous one, why we
Yes.
choose 0?
Yes, which one is the first? Check. Either
0, 0.
yeah, 0 or 1. So 0 is the first, so I
Yes,
choose the
yes.
first value. Okay,
Yes.
fine.
Yes.
Next, for this, here is 0 and here is 1. So which value I need to choose?
0.
0.
0. So 0 is Same way you can plot AI2, that means A2, A1 and A0. So I will plot A2 also, and then you can know A1 and A0. So for A2, if I want to plot, so I need to check this I2. So before the clock, we know that initial value should be,
0.
so I will consider 0 if we didn't get the initial value here. Then what is the D here?
1.
So it will be now 1. So no problem in this. Then check
1
here.
is 0.
It is 0. So it will be 1 or 0.
1.
What is the first value?
1.
So it will be 1. The drawing is so bad. So it will be 1. Okay. Then for I2, this is 0. This is 1. So which value I need to choose, girls?
0.
0. The first value is 0. Clear?
Yes.
Okay. Now here, shift register. Shift register means here there are 4 registers. And you know these registers we need if we want to shift the data left side or the right side. Okay. So this is the right shift register because if look, you can see here, if there is a 1 and here is 0, here is 0, here is 0. Okay. And if I am inserting here another input 1, if I'm giving another input 1, so what will happen? You can see that this one wants to come here. So I am giving 1 command, but in flip-flop, could you tell me that 2 bits can stay in 1 flip-flop?
No, only 1 bit.
So that means this one will go out. If it will be out, then this is the input, this is connected to this flip-flop. So this one will be here. Clear or not?
Yes.
And now,
But there is 0.
yes, because there was 0. So this 0 will go out now. Then because you are doing shifting, okay? So this will stay here now. Now this 0 will come out. So this 0 will stay here and this 0 will go out.
Oh.
No place for you. Okay. So this is called shift register. That means one by one shifting will occur because we know that for flip-flop, only 1 bit can store in flip-flop. So if there is another bit, we will give the another input, then definitely the previous one has to go out. Okay. And because these flip-flops you can see are connected together, so the output of the first one will become the input of the second. So that's why the bit which will be out from this flip-flop, it will stay in this. Clear?
Yes.
So this is called shift register. And girls, in the same way, I can make here left shift register also. So left, how can I make left? If I am if I am giving the input from this side, so this will shifting will occur from here to here. So then it is called left shifting. Clear?
Yes.
And very important thing you can see here that all flip-flops is connected together or not with the clock.
Yes, with one clock.
Yeah.
Because we want that all flip-flops should give the result at the same time. As I told you before, even for register, we are using several flip-flops at the same time. So it will be very difficult to, and you know, the result will not be synchronized and it will be delay also if I give individual command to each flip-flop. So that is very important for the register that we need to give here the same flip clock. Clear?
Yes.
So now the waveform for the shift register. So same, what we have to do here, this is the clock, this is the serial input. That means what is the data you want to shift. So you want to shift data, this is the data, 1, 0, 1. Okay. Now, here is no clock, so initial value is 0. So initial value is 0 means it will start from here 0. Now.
And 0 again.
Again, this is 0 and 1, so again 0.
Then 1.
then 1 and 0, then 1.
0, 0.
Now, if I want to draw the Q2, so could you tell me what is the input for the Q2 for this flip?
Miss, the last one, it will be 1.
No, 0. Look, here is 0.
But there is see the last line.
The last one. Yeah, here is 1.
Yeah.
Okay, girls, if I want to plot the Q2, can you tell me what is the input for the Q2 for this flip-flop?
Q3.
Q3. So I cannot consider this one as an input. Clear?
Yes.
What is the
Yeah.
input?
Q3.
Q3. Okay. So I need this. Is it clear to you or not?
Miss,
Yes.
can you repeat Q3?
Yeah, Q3 is here. What we have done, same. If there is no clock, so 0. Here is 0 and 1. So the first value is 0. Here is first value 1. So it will be 1. Then here 0. So 0. Then here first value 0. So 0. Here the value is 1. So 1. Simple as I did before. Clear?
Okay.
Now, if I want to plot the Q2, what is the input for Q2?
Q3.
Q3. So now I need to check this. So previous value before the clock, I will consider 0.
So I can't, for example, start with 1, then 3. I have to start with sequence, right?
Yes, yes. You have to start with the sequence.
Okay.
So here, what is this value?
0.
0. So definitely it will be 0 now. What is the
Then
first?
0.
And then?
1.
And then?
0. 0.
Then 0. Okay, 0. Girls, now you can see, look. Here, before in the data, 1 was here before. Now check for 1 shift. 1 was here now. Now after that, 1 is shifting to the right side or not, check?
Yes.
Shift register. Can you see the shifting is occurring?
Yes.
Yeah. So this is called right shift register. Now for Q1, what is the input for Q1?
Q2.
Q2. So now I will check this Q2. Look, 0, 0, 0, 0,
1.
1, 0. Look, 1 is here now. Shifting occurring?
Yes.
Okay.
Yes.
And for the Q0, everywhere.
All of them 0 except the last one.
The last.
Miss, I didn't understand how we shift them and this and draw.
The waveform is shifting. You can see, look, the waveform is shifting.
Yes,
Just you
but how we decide to draw like this?
As I explained before, look, I didn't explain you this circuit same way I am doing this. I didn't do anything new. The same. Here, the same thing I am doing. I didn't do anything new. It's a simple waveform. What we did for the D, same. Why are you telling me now when I am doing last one? Why didn't you tell me at Q3? That means I didn't understand Q3. And even I explained second time also Q3. You should tell me at that time. What is the benefit at the last? You are waiting till last. I didn't do anything new. I already explained these things same. It's not new.
Okay.
I will explain Q3 first.
Miss, I think she understands this, but she asked how did we conclude that this is shifting. So this is just like we...
Wait a minute. I will explain her. Look, this is Q3. So Q3, if I want to draw the waveform for Q3, I need to see this input because this is the input for Q3. So here you can see there is no clock. You know this, girls?
Yes.
If no clock, then?
0.
0. Okay. Now what is the first value here?
0.
0. So I will draw 0. Then
0.
not 0. Look, the first value. First value is 1. And here 0. Okay. The first value means you need to check what is the previous and the value is same or not. Look, because here was 1 and now it is 1 and it becomes 1 to 0. Can you see? It becomes
Yes.
1 to 0. So what is the first value?
1.
1, not 0. Okay. So first
Okay.
value is 1. And then there is no confusion for this. It's simple 0. Huh?
Yes.
Yeah. And here, look, what is the first?
0 to 1.
0.
Yeah, very good. 0. So it's 0.
Because the
Then,
previous one is 0. So
yes. Then,
then 1.
1. Correct. That's it. And look,
Okay.
what I told you, the shifting is occurring. Look, before 1 was here or not?
Yes.
And now
So,
1 is here.
yeah.
So it is right shifting. Look. Can you see? It's
Yeah.
shifting or not?
Yes. Yes.
Yeah. So that was I explaining that there is a shift register, right shift register. Same thing I can do for Q2. For Q2, you can see, look, for Q2, what is the input? Tell me.
Q3.
Q3, yes, not SI. So now for Q2, I will not check SI, okay? I will see Q3 and Q3 is this. So 0, then,
0.
okay, then
1.
check.
0.
Oh, sorry. 0.
Then what is the next?
1. Then 0. Then 0.
That's it. Clear?
Okay. Okay. I understand.
Because it is the same as we did before, huh?
Yes.
Same.
But it's complex. So I
It's
get
okay, no problem.
confused.
But what I want to tell you that you should tell me at the beginning, like Q3. Once I draw Q0, then you are saying. So then
Okay.
I was saying that, yeah, because I completed, then you said. Otherwise, no problem. You can ask several times, no issue. Because if I'm on Q3, so what is my concern? That if one point at the beginning is not clear, so tell me at that time. Because do you know, if I finish everything, then you are asking, then because that means you don't understand anything then. So if there is a confusion at the beginning, so it's better to clear at the beginning. Clear?
Okay.
Yeah. Otherwise, no issue. You can ask me, no problem. So we have done this. Okay. Now, girls, here is shift register. And this is how many flip-flops are here?
2, 3, 4, 5. No,
Five?
4, 4, 4, 4.
4 flip-flop, yes. And girls, so if there are 4 flip-flop, I will say this one 4-bit. What will you say?
Register.
Yes, very good. We'll say it is 4-bit register. Okay. Now, this is the data which we want to save in this. So what I am going to say you that first thing, that means here, can you see there is anything here in this block? In
No.
this three? No. So I can say the flip-flops are empty. Nothing is here, huh?
Yes.
Yes.
So 1011. So I am going to send first this one, this data. So if I am giving this data with the clock, because we know that the flip-flop will work with the clock. Without clock, it will not work. So the data will save in first flip-flop and the other flip-flop will be empty. So I can say E, empty, empty. Clear?
Yes.
Okay. Now, if I am giving another input, is it clear, girls, to everyone, this point? The first?
Yes.
Okay. Now I am giving the second data. Look. Second data. Actually, I am teaching using laptop, so it's difficult to write. Otherwise, I can show you to write. Here, laptop, it's difficult to write with mouse. My phone is not working. There is some problem with the Zoom, I think. Once I share, it's disconnect the Zoom. So that's why I'm explaining. So girls, here, one next digit is 1. And now what will happen if this one will stay here? So what will happen with the previous one, girls?
Shift to right.
Shifting, because we know that the output of the first flip-flop will become the input of the
New.
Second.
second one, huh? So
Yes.
this one, the before one will
Come here.
Input and the second one.
second flip-flop. That means here the shifting occurring. Clear?
Yes.
Mhm.
Okay, shifting is occur here. So now this one and this one, another two are empty. Now the third data, what is the third digit?
0.
0.
0. So if 0 is here, what will happen with this one?
We'll go to right.
Yes. And what will happen with the first one?
Also shift to right.
To the
Also
third one. To the third one.
yes, to the third one. Clear. And now the next, what is the next input is 1.
1.
So 1 will be here. This 0 is here. This 1 shifting. And this one is also shift. Clear or not?
Yes.
Mm.
Miss,
Yeah.
can you please explain how it's 4 flip-flop, not 5?
Yeah. No. I have given 4 flip-flop because there are 4 boxes. Look, can you see? 1, 2, 3, 4.
Oh, okay, thank you.
And always, girls, you can see that we will not have like 5 flip-flops, not even 5 and not 6. Like
Only
only
8 and 4.
yes, in the powers of 2, 8, because we need to use always 2-bit data, 8-bit data, 32-bit data, 16-bit data, like this, huh? Hello?
Yes, yes.
Yes, Miss.
Okay. So how you will know that there are 4 flip-flop, because here is 4 box. Can you see? So I didn't write the complete flip-flop. I didn't draw here complete flip-flop. That, and you know, whatever the data you are giving, you are saving the same data. That means it is D flip-flop we are talking. Can you see?
Yes.
Okay. That means here in this circuit, which I show you, it has D flip-flop all. Because we know that only for the D flip-flop, whatever the data we are giving, the same we will get it. Huh?
Yes.
Yes.
So that means it has D flip-flop, this shift register, as we studied before. Can you do you remember the previous slides?
Yes.
In previous slides, which flip-flop I am using?
D flip-flop.
D flip-flop. So even this circuit has D flip-flop, and even here this one I didn't draw here D flip-flop. I didn't draw here even the Q bar. Just I show you in the form of boxes.
Yes.
Any doubt till now?
Clear.
Okay.
Here, Miss.
Okay. Now what I am going to do? Look, data is finished. What was the data length? Data was 4-bit data, huh?
Mm-hmm.
Yes.
Yeah, and we had the 4 flip-flop. After the 4 clock, 1 clock, 2 clock, 3 clock, 4th clock, I saved the complete data. Clear?
Yes.
Yes.
But now what I'm going to do? I'm not giving more data. Look, data finish. Done. But I am giving the clock. Means I am giving now 5th clock. If I am giving the 5th clock, so I know that if I am giving the clock, shifting will occur or not?
Yes.
Yes, shifting definitely will occur, but I don't have any data here. So what will happen? I'm not giving any data. This one will shift. This 0 will be here. This one will here, and this one will
Outward.
out.
But why, Miss? There is no any data. Why it will?
Yeah, no, there is no data. Do you know? Because it is shift register. You see the diagram? Look.
Automatically.
Yes, look here, the shift register. Can you see?
Yes. Yes.
All are connected together. So definitely if there is no data, but the clock you are giving. So if clock you are giving, so this will come out here.
It will.
Okay.
It will work until all the boxes will be empty, or no?
All the boxes will empty. It can be if you are giving more clock. It can be. Look, I will show you. Where was this? Yeah. Maybe if you are giving 6 clock, where was the circuit? Yeah, next slide. Maybe if you are giving 6 o'clock, then what will happen? Definitely, do you know, girls, if I am, because empty will not be represented here. Like if I am, if you will do the experiment in the lab, then whenever you shift, you know, the LEDs are here. I can show you, wait a minute, like this, like LEDs here, LEDs here, LEDs here, LEDs here. So 1 and 0, how will you know? It represented by the LEDs, okay? So if I am giving the clock, so do you know this LED will glow, this LED will glow, this will not glow, this will not glow. Means you can say like 0 is here. It will consider as a 0 or empty. Okay. So that means here you can say, okay, this is empty, but because we are not giving data. So by default will be here 0, means the LED of that particular will not glow. But because it is shift register, so the shifting will occur.
Yes, okay.
Yes, and that's why it will shift. And if you give, look, sixth clock, what will happen?
It's, empty, 1 0.
Yes, so empty I represent because it will make you the clear picture. That's why I make it blank, huh? 1 0. You will give 7th, then it will be
Empty. خلاص.
yes. So
Well,
got it?
yes.
Because it's a shift register, so shifting will occur. So register is done. And now this is the question for you. The content of a 4-bit register is initially this. So what is the meaning of initially this content?
It's there already inside.
Yes, very good. That means the already register has this. That means it is not
Empty.
okay. The register is shifted 4 times. So you need to give how many clocks?
4 clocks.
4 clock. Very good. So you will give 4 clock. And you want to shift this data. Okay. So the data is this 1 0 1 1 0 1. Clear?
Yes.
Any doubt?
No, clear.
No.
Okay, fine. So now start and then tell me what will be the answer after 4th clock. Do it. Anyone has problem in this question that you didn't understand that?
Yes.
Do here? Yes.
You said for flip-flop because it said he shifted 4 times.
No, because it's mentioned here. Look. Can you see?
Okay.
Yeah, it
Then
is.
you for flip-flop.
Yes, they mention here 4-bit register means 4-bit register means there is 4 flip-flops, huh? Clear?
Yes.
Yeah, Miss Clear.
Okay. It's clear to all?
Yes.
Yes.
Wait, Miss, don't erase.
I did.
Hi, Miss.
And now it's here.
Okay, wait. Okay, thank you.
Okay, now the counters. This is the new topic, huh? Counters, girls, from the name, what do you know from counters? That means what you are going to learn in this topic.
How to count.
What do you think? Huh?
How to count.
How to count. Very good. So that means you will know that here the countings means how will you count the numbers, huh? Even you can count the time, that how much time is there. As you know, girls, the counters you have seen already. Every day you are using these things. If you remember the traffic signal lights, huh? There is some digits, some numbers it's represent or not?
Yes.
Yeah, it's written there in traffic signal light. 60 seconds. Then it counts to
59.
9 and then 58.
58.
So it is counting to backward. Huh?
Yes.
It's called down counter. What is called?
Down count.
Yes. Okay. And we can have the up counter also, like if I'm counting upside like 1, 2, 3, then we can say we are using here the counter which will count up counter, huh?
Yes.
Ascending.
And even you have in a microwave, do you remember? Yes, everyone use microwave nowadays. So in microwave, you start the button, the 30
Down.
seconds comes, huh? And then it starts 59, then go back to 0. And again, it starts to 30 once. It is not stop at 0, huh? Or 1.
Yeah, it's back to 30.
Yes, back to 30. So, do you know, this is again the down counter. So you are using counters in your daily life. Here are, these are the examples, some of the examples. So timing, building a precision digital clock is an example, which where you use the counter sequencing. Like if you have to start 2 or 3 things at the same time. Starting of a rocket motor is an example where the energizing of fuel pumps need want to start these 3 or 4 things at the same time, okay, with a sequence. So then you can use the counter. And counter measuring the flow of traffic on a road, like if you want to know that how many vehicles cross that particular, and maybe, do you know, counters we can place in the parking area. Like sometimes we went to the any mall and we parked the car underground, there is a parking, and sometimes it's full. So it was very difficult for a new person when it comes and there is no parking, he has to wait. So we can have at the outside of the parking area, that once all places booked, then we will mention the maximum parking is this, or 1 parking is left, or 2 parking is there, or it is full. So we can mention these things also there. Like we can have a sensor whenever, and the counter, whenever 1 car will pass, the counter will increase. And that exit door, we can have a counter and the sensor. When there is a car go out, the number will decrease. So we can know that, okay, there is a space there. So we can have these types of examples also for the counters, huh?
Yes.
Okay. So now, if you want to design the counter circuit, then how will you design it? So the counters increase always 1 by 1. Okay. The output value increases by 1 on each clock cycle. So definitely you need to give the clock for this, and it has also the flip-flops. Okay. And girls, if you see this state diagram, because I already explained you that how will you, when once you see the state diagram, that which information you will get from that state diagram. So could you tell me, if you see this state diagram, then what will you know from that?
We have 2 present state
Yes, very good.
because we have 4 combination. And
how many flip-flops?
2 flip-flops.
2 flip-flop.
2
Flip-flop. So if 2 present state, then how many next state?
2
next state.
2 next state. And look, you can see here input is always 1. You know why? Because always because for the counter, definitely I need to go to the next state. I will not go to the back. It's wrong for the counter. Are you getting my point?
yes.
So that's why for the counter, we have always 1 input. So even no need to write this. There is no need, because if something is always available, then there is no need to write for the counter. So in the state table for the counter, there is no need to write inputs and outputs. You can write only present state and the next state. So for the counter, if I count, so for first it is 0, 0. Definitely if it is up counter, if it is up, it will go to 0, 1. 0, 1, 2, it will go to 1, 0, 1, 0, 2, 1, 1. Clear?
Yes.
And then 1, 1, 2, 0, 0, go back to initial value, because it's mentioned already for the counter. After the largest value, the output wraps around back to 0. So it will go to initial value always. Huh? So if you want to draw the state table for the counter, then you will have the present state and the next state. So present state will be 2 definitely, and the next state will be 2 here. So, and girls, always be remember that these present state sequence, you need to write in a proper sequence. You cannot write first 1, 1, then 0, then 1, 0. No, I told you from the beginning that the sequence should be correct. Otherwise, girls, if you don't write in a correct sequence, even in chapter 5, even in chapter 6, you will get from my side 0. I will not even check your question. So it should be clear to you, very much clear. If you don't write in a sequence, I'm not going to correct your question because there is no use. I have 200 girls, and even it will be very difficult for you also, because if you want to draw the K, you have to find that which value I need to write where, which value. So that's why I will not accept. If you don't write in a sequence, then don't expect even a 0.1 marks from my side. So present state always in a sequence. So 0, 0, 0, 1, 1, 0, and 1, 1. So always follow the sequence. Clear?
Yes.
And then next state. Next state will be, look, if present state is 0, 0, what is the next?
The next one, 0, 1.
0, 1, very good. If present state is 0, 1, what is the next?
1, 0.
1 0.
Okay. If present is 1, 0, what is the next?
1
1,
1.
1.
If 1, 1 is the present, what is the next?
0 0.
5, 0.
This is the state table. Clear?
Yes.
So for counter, you can see the difference. For the counter, there is no need to write inputs and output. Present state and next state will be sufficient.
Miss, so it's constant, the previous schedule. Is it constant that it will be always like this?
Yeah, it is fixed. يعني خلاص.
It's
So
fixed, right?
It is up. If I have a down counter,
it will be start with 1, 1.
and we have another thing also. We will have like decade counter. So many things. You know that.
So this one for the down counter.
This is for the up.
Up, okay.
Look, why it is up? Because first is 0, then 1, then 2, then 3. And you know, nothing is fixed. You know that there are so many things that we can add, we can delete. So you have so many things even in the counters to learn. Huh? Look, let's see. Okay, now the counter is a register basically, because we need to have here the flip-flops and not a single flip-flop. If there is 2 inputs, 2-bit, then I need to use 2 flip-flop. If there is 3-bit, then 3 flip-flop. If 4, then 4 flip-flop. So definitely I need to use here register. Clear?
Yes.
Now, the counters I can categorize in 2 ways, ripple counter and synchronous counter. So ripple counter means you can represent ripple as a asynchronous counter. And the second one you call synchronous counter. So girls, could you tell me what is the meaning of synchronous and asynchronous? Synchronous, I already told you. I already explained you last week. So what is the meaning of synchronous?
Same clock.
Same clock. Very good. Synchronous means same clock, and asynchronous means
Different clock.
different clock. So this asynchronous counter further we can divide into up and down. And even synchronous counter I can divide into again up and
Down.
down. Clear?
Yes.
Okay. So now, girls, very important thing which I want to explain you here. The synchronous counter, basically it is the made of flip-flops. Huh? So if you remember in chapter 5, once I gave you the question for the designing, what did you do? Like if I ask you design with D flip-flop, 2D flip-flop, so you use here DA, DB. And after that, you mentioned that both has the same clock. You did or not these things in chapter 5? Hello?
I didn't remember, Miss. We connect them with the same clock.
You didn't remember?
Oh, yes, I remember.
Yeah, other students,
Direct?
not only one. Not only one, other student also. Girls, do you remember that we designed these types of circuits in chapter 5?
Yes.
It's called the direct, I think.
Yes,
Not direct. It is clock.
with the same.
Hmm?
Yes, same clock.
Yeah,
Same clock. We gave same clock. That means the chapter 5, the designing which we studied already, that is the designing of synchronous counter also. So synchronous counter means synchronous sequential circuit because it has the flip-flop. So that the steps which I taught you in chapter 5, we will follow the same steps for the designing of synchronous counter. And I can show you, wait, what were the steps? How was the circuit? Wait a minute. So that you should know it, that it's not a new thing. The same which we already, you already studied. So you will use in that counter, same steps for the designing of that type of counter. Chapter 5. See the last part. Can you see the screen?
Yes.
Yes.
Look, design a sequential circuit using D flip-flop. So first you have the state diagram. You know this?
yes,
After what I explain you, draw the state table, present state, input, next state, output, then excitation table for the flip-flop.
yes,
After that, K-map. Hello?
yes,
Then you draw the circuit and check both circuit has the same clock or not.
yes,
Yes.
That means this circuit is also synchronous sequential circuit or not.
Yeah, it is.
Okay, because it has the same clock, so that means it is also synchronous sequential circuit. Clear?
Miss, so how do we know it is down or up?
I will tell you, I will explain you these things. I'm just, I just want to relate that don't think that the counter has a different steps for designing. No, the synchronous counter, which I already explained you in chapter 5, it has the same steps. Okay.
Like first the truth table, then
Yeah, same, not truth table. You don't know, here is not truth table. We didn't say it is truth table. What we say this?
I mean same steps, yeah, from beginning to
Yes.
end.
Yeah, but what is this called? This table is called what? What is this?
Excite, no, not
characteristic.
yeah.
Very bad.
Yes, I
Is it
forget.
state table? Flip-flop
State table.
table.
Not flip-flop table. It's called state table.
Yeah,
State
state,
table.
this one.
Because
Okay,
it
state
describes
table.
the states, present state, next state.
Okay,
I said state
Yeah.
table, miss.
Okay.
just we forget.
Give me bonus.
Yeah. Bonus, Okay, so girls, remember the steps, but only there will be one difference because as I told you, for the counters, we don't have input output. You know that? I already explained you.
Yeah,
Yes.
it's
That means
short
you have
than
everything
this
same, but
table.
you don't have this. You don't have this. Clear?
Yes,
Yes.
So be remember these steps because I am going to use these steps for the designing of synchronous counter. Okay?
okay,
Sorry. So you should know the steps. That first diagram means state diagram, then state table. Then I will use that which flip-flop we want. That means then I will use the excitation table. After that, the K-map and then draw. So same steps I will follow for synchronous counter also. Clear?
Yes.
Okay. Now the next is ripple counter. So synchronous counter I will explain you later. So first I will explain you this counter, ripple counter. This is new for you. You never study, you never see a circuit which has a different clock till now. So this is new for you, okay? So because this circuit has different clock, it is called asynchronous or ripple. Got it?
Yes.
Okay, so design of asynchronous ripple counter, how to design it. For this circuit designing, so there is not steps. There are not steps as we followed for the synchronous. So directly we can design it. So I want the white screen.
Miss, can we have a break?
Break. Okay.
Yes,
Fine.
please.
10 minutes break here. So come at 1:10. Huh?
Okay.
Okay. Thank you, Miss.
Directly you can start. Like if I want to design a 2-bit ripple counter, okay? So if I want to design 2-bit ripple counter, very difficult to write. Huh? So 2-bit means how many flip-flop?
2 flip-flop.
2 flip-flop. So make 2 flip-flop. And then I want it is ripple because I know that it is ripple counter. So we cannot give the same clock. Can I give the same clock?
No, it's different.
Yes, we need to give the different clock. So I am giving here this clock. This is the clock. And how can I make the different? Here is JA flip-flop. Here is KA. This is JB. This is KB. Okay, so this will be A, this will be A bar, here B and B bar. And if I want to give the different clock, so how can I give the A output will become
Clock.
clock for the second. Now it will be different or not?
Yeah, it's different, but why?
Because we want to make it different. That's why.
Yeah, but is it necessarily to be connected with the before one?
Yeah.
Can we connect it with A bar, for example? Or no?
Yes, you can connect and then you can check what will be the result comes. Okay.
Okay.
The type of flip-flop like up or down something. So you can check, you can connect with A bar also and check what will happen. Okay. So I'm going to explain you now. If I connect with A, then what will happen? Huh?
Miss, why did you put bubble in the clock?
I will tell you later because I'm giving now negative age. Bubble means, you know this, huh? Bubble
Oh,
means,
okay. Negative age. right?
Negative.
yes, negative, huh?
Yeah.
Do you know what I'm going to do here? J and K, I am connecting with 1, 1. JA and KA also I am connecting with 1, 1 always, huh? For the complete operation, complete cycle. So now I am going to give the clock here. I am give the clock. So it will work with positive or negative age?
Negative age.
Negative age triggering. Okay. So that means the result I will get here. I will get here. I will get here. Then I will get here and here. Any doubt till now?
No.
Okay, now let's start. What will happen here? So first I will draw the A result. Huh?
Mm.
So what is the waveform for the A, first flip-flop? So let's start to draw. If I want to draw the waveform for first A flip-flop, so the clock is negative. So before the clock, because this area is before the clock, this portion. So before the clock, the value will be
0.
0. Here is the time to change the result. So if I want to change the result, I will go to the circuit. So for this circuit, JA and KA is connected to 1. So remember the truth table for GK flip-flop, girls?
Yeah, the opposite.
Yeah, if
Q
complement of
bar,
previous,
Q bar, yeah.
if both are 1. So previous is 0. So what will be the result here?
1.
Is it clear?
Then 0, then 1.
It's clear till here or not?
Yeah, Miss, clear.
Yeah, yeah,
Okay.
clear. It's the
Now,
JK
yes, now again it's time to change the result.
to
So
0.
A and K is connected to 1 and previous value is 1 here. So what we will get now?
0.
We'll get 0. Now again time to change the result. So what we will get here?
1.
1.
Now
0.
Then
1.
1.
0.
clear?
Yes.
Yeah, clear.
Now, if I want to draw the waveform for B, so for B, can you tell me the clock is this or this?
No, for the A.
No, for A.
A. That means A is the clock. And A is positive age triggering or negative age triggering?
Negative.
Negative age triggering. That means the result we will get here and here. Am I right?
Yes.
Miss, you mean because of the bubble?
Yes, you don't know. It is negative. If bubble is
Yeah.
there, negative age triggering. Huh?
Yeah,
Yeah.
clear.
Yeah. So that means where I show you the arrow, the green arrow, not the red, the
Start
green
from
arrow.
here.
So at that point, you will get the results, huh? Clear?
Yes.
So now, how can I plot the waveform for this? That means I can consider from here to here that no clock. Okay? Clear?
Yes.
So if there is no clock, so then memory.
0.
And what is in the what is the initial value? We consider always 0. So
0.
that means I will get till here 0 or not.
Yes.
Yeah.
Okay. So if I am getting till here 0 and then it is the time to change the result. So now check.
1.
Is
It
JB
will
and
be
KB?
1.
Yes, it is connected to the 1. So complement of the previous. So previous was 0. It is
1.
1.
1. Then
0.
0. Got it?
Yes.
Now, if I want to check that what did I get here? So here is 0. This is 1. This is 0. This is 0. This is 1. This is 1. This is 1. This is 0. So I will consider the result for 4 clock. Okay, once I am getting the clock, because these results are the initial. So I will not consider this result. So 0, 1, I will consider first B and then A. Okay. So what is B value? 0. A value 1 and B value is 0
1, 0.
and 0, and this is 1 and 1. This is
0, 0.
Can you repeat, Miss?
look B and A first. So what is B?
0.
So 0 and 1 I am writing. Then what is B here?
1, 0.
1, 0. So I wrote 1, 0 here. B1 and A1 1, 1 here. B0 A0. So 0, 0. Check 0, 1 2 3 and then go back to 0, and again if I plot here I will get 0, 1. Okay, you can see even I will get here 0 and 1. Here is 1, here is 0. So can you see that which counter you have now?
Up counter.
Up counter.
0 1 2 1 0
1, 0.
1
Then
0
1,
2
1.
1 1
And 1, 1 to 0, 0.
0 0 and 0 0 2.
So 1. Yes, I have a question. Always,
Wait a minute. So girls, in this way you can see that we are getting the up counter. Okay, and now I want to give the question which you asked in the at the beginning. Here negative age. If I am giving here negative clock, then I am getting this result. Okay, so the result which I am getting up, this is for this result, the negative age triggering is important. This negative which I gave. Okay, and girls, some girls even ask me for to connect A bar to the second second flip flop. Yes, you can connect and check that what will you get it. Okay, so you can connect it and then you can check it. Maybe I can give you as an assignment for the next class, so you can connect with the A bar block and then check what will be the waveform. Yes, now you
We
can
can just said that it's up counter.
yes ask who is asking the question here. What is the question?
You mean when we mentioned that it's up counter, we must mention that it's from the negative clock?
Yes, yes. Do you know if you don't use the negative, if you use the positive age, then it will be.
You mean in the drawing or in the final answer?
Why final answer? Final answer is this. This is the final answer. In the drawing, I did this clock. Which thing I use negative here, dear?
Okay.
I use here the clock. So I am talking about the clock now. So if you want to implement as a up counter, then you need to use the negative age triggering. If you are going to use the positive age triggering, then what will happen? You can check it. I will give you the question and you will do all yours. So if I am using here negative age, then I will get up counter. Clear?
Yes.
Yeah, Miss, clear.
Okay. Any other question?
Miss, for the value, always it will be 2 to the power n. Yani
Yes,
from
2 to the power
0
n.
to 3 always. Then 0
Yes.
to 8. We can't, for
0
example,
to 7.
8 to 7, yeah. We can't, for example, do it with 0 to 5 or 0 to 6, right?
You can do that also. I will explain that thing also later. You can do it.
Yeah.
0 to 5, 0 to 6. You can do that. No issue. I will explain that part later. Okay. Hello.
Yes, clear, yes.
Okay. So this diagram is clear or not? Tell me. Hello.
It's clear.
Clear, Miss.
One thing you didn't ask me, the other group girls, they asked me why J and K is connected to the 1. Do you know, girls, for this ripple up counter, we need to connect J and K all with 1. Because for this waveform, if you can see the waveform, we need these things that 1, 0, 1, like 0, 1. So I am going to use the property of JK flip-flop whenever it is connected to 1, 1, it gives me the complement of previous. So I need to use that property. That's why I am connecting JK with 1, 1 for this waveform. I cannot give here J always 1 and K 0 because J is always 1 if it will give me always 1. So I will not get this waveform. And even if I want to connect K always 1, then it will give me always reset. So our motive will not fulfill. So for this one ripple counter, I need to connect always J and K with 1. Clear?
Yes.
And another
Miss, please, how what do you mean by JB and JA? It will be always 1 if it's 1.
otherwise you will not get this waveform. What I'm saying, if you don't connect with 1, 1, you will not get this waveform which I gave you.
What will happen if it's 0?
So if it is 0 or 1, always, do you know, if J is 1, always be 1, you will get whenever the clock, you will get 1, 1, 1, 1, 1, 1. So
Okay.
yeah.
You
this
mean in the equation of JK flip-flop?
equation? No, you do you remember the truth table or not?
Okay, yeah, I remember.
Based on the truth table I am talking about.
Okay.
Yes. And now, girls, if I ask you to implement the same circuit with T flip-flop, can you do that?
Yes. But Miss, I have a question. If it will be always J and K 1 and 1, why it will give us different answer if we connect A bar as a clock?
No, you can connect. I'm telling you, you can connect A bar and then check what is the answer. It will give you up or down counter. One counter will work with this also. You can check it.
So
Just
it will give me the same.
Not same, I cannot say because I didn't draw the waveform, but it's working. It will work, I think, as a up or down. You can check it.
Okay.
Because I explained the method. So now you can do R&D, you can change with A bar and check what will happen.
Okay.
Okay, so now in the given diagram, girls, if you understand how to get the waveform, so now you can change anything and then check how will you get the waveform and which circuit you are getting, so you can do yourself. The question next, yeah, what was I saying? Yeah, can we do this circuit with T flip-flop or not? Tell me. If yes, then how?
We connect the T, remove the K. We connect the T as a clock for the second
Clock.
circuit.
Yes, give me the answer, girls. Girls, for a T flip-flop, do you have the any condition then that the flip-flop gives you whenever it is something like any value and it gives you the complement of previous?
No,
Really? T flip-flop, you don't have this?
we have for the JK.
Only JK? Really?
I didn't understand the question.
The question is, for T flip-flop, do you have any condition where the T flip-flop, that means you are giving any value of T flip-flop and it gives you the complement of previous?
No, there is no condition like this.
Did you study chapter 5?
Actually, yes.
And give the quiz also, huh?
Miss, please don't talk about the quiz. Please.
So do you know, if you know, if
No, Miss, don't laugh. Don't laugh. It's not funny, Miss. Please.
if you don't listen, if you don't know the truth table of T flip-flop, then really, do you know whatever you did in the
T
quiz that
flip-flop, it will give me the XOR for the second.
yes, but do you know, dear, listen, the truth table for the T, you don't know. Look, what I mean.
Miss, that, yeah, like she said, it will give us the XOR.
Yeah, it gives the XOR, but listen, look what I'm saying. If T is 0, it gives you QT. Do you remember? And
There is the QT.
if T is 1, it gives you QT bar or not?
Oh, yeah. Sorry, Miss. Yeah.
Yes. And you are saying no condition.
No, Miss, yeah, I'm sorry.
Yes, so T has also this case. That means whenever I am connecting T to 1, it gives the complement of
previous one.
So look, that means in the same way, I didn't do anything. I just connect TA and TB with 1 and I will get the same waveform. So I can implement the 2-bit ripple counter, up counter. I'm talking about up. So I can represent 2-bit ripple up counter with T also. Understand?
Yes.
Miss, it will be like, you know, the waveform?
Waveform is very easy. You can draw it. I will give you the question and you will draw yourself. Then it will be easy for you. I will explain. I will give you the circuit and you will draw it yourself. Okay. So it's very easy. You should not do any other thing. It's just simple waveform, which you already learn in chapter 5. This is the part of chapter 5 you can see. Because I taught you in chapter 5 how to draw the waveform in a clear way. Huh?
Yeah.
You will give them also one value always?
This circuit has always 1 1. Do you know, if you don't connect with 1 1, you will not get this up counter. Try
for all
yeah.
flip-flops.
Yes. That means for JK and T, I explained only JK and T till now. I didn't explain the D now. Okay. Fine.
Yeah.
Yeah. So this is TA, TB will be 1. Okay. Now, girls, you need to, what I am going to do now, look, draw the waveform of this without the bubble. That means,
give me down.
yeah, this is the same circuit which I taught you. Same circuit, everything is same except the bubble. Look. And if you do you want with JK or do you want with T? Because both will give the same answer.
Anything, عادي.
Okay, so do with T.
The age will differ, right? It will be positive age.
Yes, because of the age. Now it will be positive age. So you will get the result where? For the
Down.
not negative. You will get the result for the positive, huh?
Mm.
Yes. So where will you get the result? So here.
Here in the
Show you.
pairs.
Yeah. Will you draw yourself, girls? Please try it. If you don't get it, I will explain. But first give yourself try, at least, so you will know that how much you understand. And do you know it is the chapter 5 part. You already know the waveform, how to draw. So first draw the waveform for A and then draw the waveform for B and look what will happen. What will you get it? Huh? Draw it.
Here in the screen.
Hmm?
In the screen.
Okay, can anyone draw on in my screen?
Yes.
Yeah, draw it then. If you are able to do that, it will be good. So all can see.
It's here 0.
Yes, for initial value 0, good. And now T is connected to 1, so 1, very good. Then complement of previous, so 0, good. Then 1, okay. Then 0, okay. Very good. Yes, correct. Now B, draw B. Positive, yes, correct. So this is 0. And then here positive, okay. Then 0, then positive, very good. Yes, you understand. Now write 0 and 1.
Here 0. Here 0.
Yeah. Very good. Yes. Now check. What are you getting? What is the value? First write B and then A. Okay. First B and A. 1 0. Yes. Very good. Tell me which counter is this, girls?
Down.
Down
Down
counter.
counter. So if you are giving the positive age, then it becomes the down counter. That's why I was using negative age triggering there. Clear?
Yes.
Understand?
Can I say that always JK and T flip-flop are the same?
Absent? What?
Are the same.
No, you cannot say. Only one condition is same. You cannot say J and K is same because JK flip-flop has 2 input. It has reset condition. It has set condition. It has.
I mean for the waveform. For this.
For this circuit, yes, it will give the same result if you are giving connected with 1 1. Then
Just don't erase. Wait.
okay.
Can you complete the 1 and 0?
She has done. Arva already done. She wrote
No,
on
that one, your left hand.
a state diagram. It has name.
Okay, the state diagram, yes.
Yes, a state diagram. So what is the state diagram here? First you are getting 1 1, then you are getting 1 0.
1 0, then
Yes.
0 1, then 0 0. 0 0 1 1.
And after 0 0 1. It is down counter. What is this?
Down counter
Down counter.
with
Two-
T flip flop.
2-bit down ripple counter. Okay.
Mm-hmm.
Got it?
Yes.
Hello.
Yes,
Clear?
yes.
And girls,
Clear.
you can draw this diagram using D also. Can you tell me D has
But how, Miss? It will not give me the previous.
yeah, that's why I'm saying, but for the D flip-flop, if you are giving here 1, it will give you 1. If you are giving 0, it will give you 0. So for D flip-flop, how will you get the complement of previous?
How?
Tell me.
1 1.
Hmm? Can we do
Connect the output as a clock.
not output? No, 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 no. What should we do?
The input.
I want always complement. So
With the bubble.
yeah, with the bubble, very good. Yes. So if I connect, look girls, what I'm going to do. So I am going to present with yellow color, new color. Huh? Can you see? B bar will be the input. Here A bar. So I will get always the complement. Hello?
How, Miss?
I will get the complement or not. Look, if I am giving here 1, what will be the result now? 1?
1 0.
No, what we will get?
1.
We will get 1. But
No, 0, Miss, because it's
at the
from
D,
A1.
at the D, it will be the complement or not?
The complement, yeah, it will be 0.
Yeah, the complement. So always you will get the complement. So you will get the same table, same waveform. Because if it is here without bubble means it will give us up, no down. If you will place here bubbles, then it will give you the down. Same
So,
way,
Miss, if it's a positive clock, it's always up counter.
it always, no, if negative, then always up. If
it's
then always
negative
down.
clock, then it's up counter.
Yes, yeah.
It's always like this
Yeah.
in any type of flip-flop.
Yeah, yes.
Okay.
Not any type, only ripple counter we are talking.
Okay.
Yeah, only ripple. Huh? I'm not saying the synchronous counter. We are discussing now ripple counter. Got it?
Got it.
Yes.
Okay. So, Arva, can you erase?
Yeah, sure.
So, and girls, do you know this counter, because it passes with the 4 stages, 0, 1, 2, 3, these stages. That's why this counter is also called mod 4 counter. What is called?
Mod 4 counter.
Mod 4, because it passes with the 4 stages. Huh? So it is also called mod 4 counter. Now, in the book, they draw the circuit for 4-bit, means we have 4 flip-flop. So it will be, you can say like mod. Which mod is this? Tell me, if there are 4 flip-flops.
4 with 4.
Really? 2 flip-flop, we said 4.
16.
8.
16.
This is mod 16 counter because it is 4 flip-flops. So it will go to the states from 0 to 15.
Oh, combination
Counter. Clear?
Yes.
So this is the circuit for T, and it is the same as I explained you. Same. T is always connected to 1, you can see. And they have given the reset also. If you don't want to give, don't give. And the output of the first one will become the clock of the second. So same circuit. Don't confuse that it is new circuit. No, it is not new. It is the same as I explained you. Clear?
Yes.
Same for the D also here. So this is for 4-bit. Okay. Now, okay. Tell me, this circuit is up or down?
Down.
Down.
Down counter. And
Yes.
it will count how many states?
8 stage.
8 states from 7 to?
0 to 7.
0 to 7.
Not 0 to 7, dear. You told me it is
7
down.
to 0. Okay.
Yeah,
7
to 0, yeah.
Yeah. And look, if I place here bubble, then what is this?
This 0 to 7.
0
This
to
is 0
7,
to
and it
7.
will be
Yes.
up counter.
Very good. Yes. Then it will be up counter. Look. Okay. So it will count 0 to
To
7.
7.
7.
Okay. And girls, so it will count for 0. Then it will count to one state diagram. Then it will give me 2. Then 3. Then 4. कौन आया था? 4, 5, 6, and then 7. After 7 goes to 0. Clear?
Yes.
So 0 to 7. Huh? So this is called up counter. Here, girls, she asked me that can we have a counter which goes from 0 to 5? So this counter which has this circuit, could you tell me what is the mod of this?
7.
Huh? Mod?
Mod 8.
Mod 8, very good. But if I want to design mod 5 up counter, then what do you mean by mod 5? Tell me.
It will go to 5 only.
Mod
0. 4. Sorry. It will go 0 to 4.
5. Yes. So this is mod 5 counter. Means mod 5 counters will count how many states?
0 to 4.
4 from 0 to.
Yes,
0
0 to 4. That means it will count from 0 to 4, and whenever comes 5, then it should go to
0.
0. That means this counter should count 4, and after 4 it should go to
0.
0.
0. Can you see the yellow line?
Yes.
Yeah.
Yeah. So after 4 it should go 0. So could you tell me, girls, in this diagram, do you have anything that you can make it 0 at after 4? After 4, 0.
What?
Like, do you know for this count?
Bubble.
Bubble, which bubble? No, wait. Did you understand my question? Actually,
Miss, can you again explain
I
why
will repeat.
from
Yes, I will repeat. What I am saying, I want mod 5. Clear? For mod
Yes.
5 counter, first you should know that how many flip-flops you need for this. So do you need 2 flip-flop for this? Tell me.
No, 3 flip-flop.
Yes, 2 flip-flop will not be sufficient. Why? Because 2 flip-flop will give me only 4.
0 to 3.
Yes, 0 to 3. So I want 0 to 4. That means I cannot use here 2 flip-flops. So definitely I need to use here 3 flip-flop. Is it clear?
Yes.
yes?
If I am using 3 flip-flop, but 3 flip-flop will give me 0 to 7. But I don't want 5. I don't want 6. I don't want 7. So I want to remove this. So how can I remove this? What should I do? That means the diagram is this, correct diagram. But I need to do something in this diagram so that it will not count. It will not give me the result at 5. It will not give me the result 6. It will not give me the result 7. Till 4 it works normally, till 4. And after 4 it goes to 0. Understand?
Yes.
Okay. So could you tell me that, do you have anything here in the circuit that by using this you can make 0, 0, 0?
The
It
reset.
should be the third one.
The reset. We can connect
Yes,
reset.
yes, good, very good. Reset. Yes, I will use this reset. That means whenever I'm getting 1, 0, 1, 5. Once I'm getting 5, do you know what I will do? Look. I will use from here wire, from the output, from this output wire. So this is giving me 1. This is giving me 0. So I will use NOT gate. And then it gives me 1 also. Here is also 1. And this is already 1. So this one, and this one. All are 1 or not now?
Yes.
And then I'm using AND gate. It gives me 1. And this output of AND gate will go here for clear, will go here for reset, will go here reset. That means whenever 101 occurs, whenever this 101 is here, then the flip-flop, all that means the signal will go here to the AND gate. It should be 1, and the all flip-flop will become reset. And if it is reset, the flip-flop will have 0, 0, 0. And whenever they are getting 0, 0, 0, the counter will go to now 1, then 2, then 3, then 4, and then it will go to the 5. But it will not display 5, it will display 0.
0. But
And
Miss,
then
always before it's reached the AND gate, I have to make it 1, 1, 1.
it depends. Do you know, maybe in the another circuit I gave here bubbles, so then you need to check the AND gate will be enough for you then if I have bubbles here. So you need to check based on the circuit. Okay.
Mhm.
So that the point is clear or not, how to make mod 5?
Clear.
Okay. It's so dirty, huh? Okay, so now, and you know, this type of counter is called decade counter. What is called?
DK counter.
Decade counter, because you are going to reduce some states, huh? So it's called that counter. So we have done this decade counter also. Now they are designing here mod 6. So mod 6, could you tell me mod 6 means how many states?
0 to 5.
0 to 5 normally, but at 6 it will give me
0.
reset. Clear?
Yes.
Okay. So if 6, it will give me reset. 6 means 0, 1, 1 here. Can you see? Because if you remember, I explain you, first you need to write B and then A. Do you remember this or not?
Yes.
So if you are getting 6, so that means here will be 1, here will be 0. No, you should write here 0, here 1, and here 1. So that's why I am going to connect this one with the NOT gate. Here is 1, here is 1. So I am getting 1, 1, 1, and I will get 1, and then it will go to the clear, and then I will get the mod 6 result. Clear?
That's what do you mean by BA?
I explain you there in chapter, in the first beginning. Look what I did here.
The normal one is 0 for the 6, 0, 1, 1.
Yeah,
The
what I did
normal.
here. If I want to write 1, how I will represent 1? Tell me.
The opposite, 0, 1.
Yeah, so same thing you will do there.
For the okay.
Yes, because here, look, if you will write AB, A is 1 and 0, you will not get the sequence, huh? So what I do, you need to write here first B value and then A value.
So if I want to use it in the circuit, I have to switch
Yes.
the.
Yeah. Clear?
Yeah.
So now we have done decade counter. We have, yes. Now BCD ripple counter, same thing, because it is ripple BCD number from 0 to 9. So at 10, what will happen at 10 should be reset. And look, girls, here it's very important thing. Look here, clear with bubble, huh?
Yeah.
So that's why I use here
Bubble.
NAND gate. So you need to check that do you have bubble at the for the reset you have without bubble. According to that, you need to use that particular gate. Maybe you can use XOR, maybe you use another gate. So it's your choice, huh? Which gate you are going to use. But here in the slides, I show you when you have to use AND gate and when you have to use NAND gate. Clear?
Why he didn't take the output for the other flip-flop?
You can take, no problem. You can take with this here, NOT gate, no problem. You can take this also. They implement only just 2 inputs, but I will suggest you to implement with all. That will be very good because there will not be chances of mistake. In that circuit, if you will choose some particular, then there can be the chances of mistake. But as I explain you here and here, as I explained you before, in that type of circuit, there will not be a chances of mistake if you will take all outputs. Clear?
Yes. Can you do it with the other gate without NAND, the normal gate, the AND gate? How it will be?
I did. Here it is with the AND gate. No.
No, with the bubble.
With the bubble, we cannot do with the NAND. If you want with the, okay, if I have here bubble, look, then no need to give here NOT gate. You know, because this will give me 0. And here is also bubble. Here is also bubble. So if you will give here, you will get here 0. Then 0 and 0 will understand, okay, I have to be clear. Got it?
So it will back to the 1.
Now it will be reset.
No, not reset because it's 1.
Yeah, so it won. That means the flip-flop will understand that I have to be reset. I explained these things clearly in chapter 5. With with preset, I explain you how the flip-flop will look. Before, what were you doing before? Look, you are getting 1 here or not? And the same one you are giving, and then I told you reset, then you said, yes, miss, it will be reset now. Why are you saying at that time it will not be reset? Tell me.
Okay, because I thought that it's have to be 0 inside the box. Yeah.
No. No. That means whatever with the bubble, the result should be 1. Then this command will work. You know, if you want to give some command, definitely this should be high. Otherwise, this command will not work. As I explained in chapter 5 for direct inputs, do you know, I explain you clearly if there is a reset and set. So if it is 0, then it will not work. If it is 1, then it will give you the result based on the command. Yeah. Okay. Anyone has question?
No, clear.
Okay, so this is BCD ripple counter design with JK. I explain you here also with JK. This is good circuit, huh? So try to use this circuit with 1. Don't use this. Huh?
Can I go to the lighthouse?
So this circuit they design with in the book. This is in the book. This is with JK. So you can design in this form also, but I will prefer to use this simplest way. Connect J and K with 1 and then do this. This will be the easy. No need to do this. Now here, BCD ripple counters. So if you want to design like you want to connect more BCD counters, so then you can connect in this way. Like you have 4 flip-flops. That means here is 4 flip-flop, 1, 2, 3, 4. Here is also 4 flip-flop, 1, 2, 3, 4. Here is also 4 flip-flop, 1, 2, 3, 4. So you are connecting 3 BCD counters in this way. The last clock will be the input for the next, and this last clock. In this way, you can connect so many. Clear?
Yeah.
And you know where are you using these things? If you remember in traffic signal. Traffic signal, if you want to present 120 seconds, so how many BCD counter you will use?
What's this? Can you repeat?
If I want to represent 120, so how many BCD counter you will use?
120.
Numbers. This is numbers.
2 power 7.
No, 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 no.
Miss, can you repeat? I didn't get it.
What I'm saying here, if I want to represent like 30 seconds, huh? So how many BCD counter I will use?
2.
2, because one will represent 3, one will represent 0.
Yeah.
3 digits.
The digits. Okay, 120, we will use 3.
3. Yeah.
Yeah. So if I want to represent 3 digit, means I need to use 3 counters, BCD counters.
Okay.
Yes. Okay, girls, could you tell me, did you feel any drawback, any disadvantage of this circuit? Did you notice any disadvantage of this circuit?
Yes, it depends on the previous.
Very good. Yes. Because do you know, if I want to write first Q1 value or I want to get the result of B, can I get the result of B without A?
No, as we did in this.
Yes, dependency. The second one is depend on the first one. So that means there is some delay. Okay? So these types of counter has a disadvantage of delaying because the second flip-flop has to wait for the output of the first flip-flop. Without the first flip-flop results, we cannot get the result of the second. So this is the disadvantage of ripple counter. Clear?
Yes.
Okay. So, but girls, disadvantage not like that we cannot use this. We can use it, and because for to remove this disadvantage, to overcome this, we can use this synchronous counter. But in some cases, based on the requirement, we are using also asynchronous counter and synchronous counter. So synchronous counter, I will explain you inshallah in the next class, and which is related to the designing of sequential circuit, which you already did in chapter 5. So it will not take too much time. It's very easy because you are familiar with this.
Inshallah.
Inshallah. So I think everything is clear now.